it can be seen that it has actually imported multiple OLE functions, such as the OLE create from file functions, which would allow the creation of an embedded object from the content of a named file. And another function that we need to take note of is the OLE create link to file, which is capable of creating an object that is linked to the file that are not aware of OLE as well. And as well as those that uses window packager, this would suggest that the malware might intend to create an embedded object to another file. Since it is seen as a PEID malware, it will very likely use this function to infect the .exe and .scr files in the victim system. So next we'll look into other DLLs, such as the OLE32.DLL. As seen, it has also imported many registry-related functions. And now we need to take note of this particular function called setThreat_token, which is likely to be used by the malware to assign and impersonate the token to a threat. Furthermore, it can be seen that it also imports the set security descriptor DACL function, which will allow the setting of information in the discretionary access control list, in short DACL. This would suggest that the malware might have the intention to modify this list that is attached to the object in the Active Directory, such that it would include itself to have access to the object, and also specify what kinds of operation that it can perform on the specified object. This will allow the malware to make modification or even spread infected virus to these object files. So now we also look into W32_32.dll. It can be seen that actually a part of the imported function is imported using ordinal value. So actually we can see that it has imported multiple WSA functions, and one of it we want to take note is WSA socket A, which allows the creation of a socket that is bound to a specific transport service provider, and socket is often used to listen and send data to the network. Secondly, we also want to take note of WSA connect, which is used to establish network connection to another socket application, which enable the exchange of connect data. And thirdly, the WSA send function allows the sending of data on the connected remote socket. All this suggests that it is likely that the malware is attempting to establish network connection to another domain. This is also found previously in the VirusTotal report, which shows the domain URLs and the IP address of the network that the malware is intending to connect to. It would suggest that the malware might be attempting to send data from the connected network into the victim system, which might be the drop files that we seen previously in the VirusTotal reports. And for more details of the analysis, it can be viewed in the report for other DLLs. So now I'll move on to the string analysis using BinText. So with BinText, it will help to extract strings, which allows us to identify some functionalities of the malware by looking for host-based and network-based indicator in these strings. So actually we can see some host-based indicator such as the ping exe file, and we are also able to locate an XML file header, this part, which might indicate that the malware might be writing information to an XML files. There are also some network indicator found. So we can see some of the URLs that we've seen previously in the VirusTotal report, which is also a network-based indicator, such as the http www.176win.com. However, we have actually also found a new network-based indicator, which is this one. They are not seen previously in the VirusTotal report. And with these URLs, this suggests that the malware has attempted to establish connection to the above URLs. And actually, we can also see 3 registry paths. And this might indicate that the malware are actually making changes to the registry. And we can also see some of the imported functions that are previously seen in the Dependency Walker. And the imported functions. And we have also actually noticed new DLL such as the mscovey.dll as shown here. This indicates that external DLLs are actually being imported and was not identified by Dependency Walker. These are all the imported functions. You can actually see some interesting strings here. This indicates that there are information added by the malware, and this might be some message that the malware might want to display to ask for input to create a new files into the designated disk drive. As shown here, destination disk drive is full. You can also see that actually there are also multiple error messages extracted by BinText. And this might indicate that the malware is actually attempting to create a new document and save it. And it also attempts to send mails using mail system DLL. The malware has also attempted to open a file that seems to be too large to open in the system. All this process might have failed to take place as we did not run the malware since we are now in the stage of static analysis. As such, there are error messages being generated. So with this, we can conclude that through basic static analysis, we are able to see that the Win32.Pinfi.B malware is not new and has previously been analyzed before by other antivirus that we saw in VirusTotal. We have found that the malware did not have any obfuscating techniques such as packing using PEID. We are also able to obtain other administrative information such as the date and time where the malware was created using PEview. Additionally, we have identified that there are a total of 13 DLLs that are mainly used, and each of them have a certain imported functions using Dependency Walker. This tells us more in-depth details of the function that the malware could be used maliciously and also indicate the functionality of it. Lastly, we have extracted some strings from the malware which gave us some idea of what the malware does using BinText. With that, we have also discovered some new DLLs that was not shown in Dependency Walker. Therefore, basic static analysis was able to give us an overview of the malware, its functionalities, and things to take note of during dynamic analysis where we will run the malware. However, we still do not know how the malware makes use of those imported functions to launch its attack on the victim system and the process of it. To do so, we will have to conduct advanced static analysis where we will go more in depth into the assembly code in the next video. So, thank you for watching.